students, today we are going to discuss about one of the most important topic in 10th class, that is trigonometry. It is a very important topic in 10th class. The topic is trigonometry. The father of this topic is Hipparchus. He is a Greek mathematician. Trigonometry is nothing but, we can divide three parts: trigonometry. Tri means three, goni nothing but gonia, metri nothing but measurements. So goni nothing but angle. Three angle measurement of a right angle triangle is called as trigonometry. Tri means three, gono, the word is derived from the gonia, Greek words gonia. Goni nothing but angle, metri nothing but measurement. Three angle measurement of a right angle triangle is called as trigonometry. Father of this topic is Hipparchus. The topic trigonometry is very important topic in 10th class, even though in plus 1, plus 2 also very important topic. Now I have some trigonometric ratios like a sin theta, cos theta, tan theta, sec theta, cosec theta, cot theta, and identities and its applications. Now step by step we'll discuss about all the 1 mark, 2 mark and 4 mark questions, even though including objective bit also will cover. In the first session we'll cover complete concept. After that we will go for the problems. Right? Now trigonometry is nothing but, we know that three angle measurement of right angle triangle is called trigonometry. The entire topic trigonometry is studies of relationship between the angle sides of a right angle triangle. Now if we take the right angle triangle ABC, right angle at B, right angle at B. In this case theta is nothing but angle, theta, which means that angle is denoted by theta. Right angle triangle ABC, right angle at B. For example, theta is angle at A. We know that in right angle triangle ABC we have three sides are there. One side is AB, other one, next one is BC, other one is AC. AB, BC, AC. From these three sides, the longest side is called as hypotenuse. The longest side of a right angle triangle is called as hypotenuse, which means that in this figure AC is called as hypotenuse. Side is called as hypotenuse. Sometimes in objective purpose, in right angle triangle the longest side is called as hypotenuse. One more definition for hypotenuse: the side which is opposite to 90 degrees is called as hypotenuse. Now the side which is opposite to theta is called as opposite side to theta. The side which is opposite to theta is called as opposite side. The remaining side is called as adjacent side. Now we have three sides. One is hypotenuse, one is opposite side to theta, one is adjacent side. Now three sides. Now first of all we will discuss about fundamental trigonometric ratios. That is number 1, sin theta. Sin are called as sin also. The word sin are from sine, S-I-N-E, sine, like a cos, cosine, tan, tangent. We know that. Now sin theta, which means that opposite side to theta by hypotenuse. The sin theta is equal to opposite side by hypotenuse. The second one is cos theta. Cos theta is equal to adjacent side by hypotenuse. Third one, tan theta is equal to opposite side by adjacent side. These three are the fundamental trigonometric ratios: sin theta, cos theta, tan theta. Sin is nothing but opposite side by hypotenuse. Cos is nothing but adjacent side by hypotenuse. Tan is nothing but opposite side by adjacent side. In this case, sin theta is equal to, opposite side is what here? BC by AC. Now cos theta is equal to adjacent side AB by AC. Tan theta is equal to opposite side by adjacent side. So opposite side BC by adjacent side is AB. So BC by AB. Now we'll go for its reciprocals. Now we have here sin theta, cos theta, tan theta. These three are the trigonometric fundamental ratios. Now we'll go for its reciprocals. Now reciprocal of sin theta, cosec theta. Cosec theta is nothing but 1 by sin theta. Cosec theta is the reciprocal of sin theta. Nothing but hypotenuse by opposite side. Now sin theta, see that opposite side by hypotenuse. Now cosec is nothing but hypotenuse by opposite side. Now reverse it. Next one is a cos theta. Its reciprocal is a sec theta. Sec theta is equal to 1 by cos theta. So cos theta is equal to adjacent side by hypotenuse. Now sec theta is equal to hypotenuse by adjacent side. Now third one, the reciprocal of tan theta is equal to cot theta. Cot theta, nothing but 1 by tan theta. Now is equal to tan theta is equal to what we know, opposite side by adjacent side. Now cot theta is equal to adjacent side by opposite side. Now adjacent side by opposite side. From these, just you observe that we will get here. We know that if you take the variable x, the reciprocal of x nothing but 1 by x. If you multiply the number, its reciprocal equal to always 1. For example, the number is x, its reciprocal 1 by x. Yet cancellation answer is equal to 1. In the same way here also, cosec theta is equal to 1 by sin theta. Nothing but cosec theta into sin theta is equal to always 1. Sin theta transport to left side part. It will become these two are multiplied. Cosec theta into sin theta is equal to 1. Transportation. Now here also sec theta into cos theta is equal to 1. Third one, cot theta into tan theta is equal to 1. X into 1 by x equal to 1. Now cosec theta into sin theta is equal to 1 from these, and sec theta into cos theta is equal to 1 from these, and cot theta into tan theta is equal also 1. Sin, cos, tan, these three are the trigonometrical fundamental ratios. These three are the its reciprocal of the fundamental trigonometric ratios. Sin to cosec, cosec to sin, cos to sec, sec to cos, tan to cot, cot to tan. From this, if you observe that tan theta is equal to opposite side by adjacent side, we know that. From these, from the definitions, we observe that tan theta is nothing but sin theta by cos theta. This is one more point, one more note, keep in mind. First one, second one, third one, this is the fourth one. Tan theta is equal to sin by cos. How we got to see that? Tan form, tan concept we know that. Opposite side by adjacent side. So if you take the sin definition is what? Opposite side by hypotenuse. By cos definition is adjacent side by hypotenuse. Hypotenuse get cancellation. Remaining we get opposite side by adjacent side. Opposite side by adjacent nothing but what we know, tan theta. That's why sin theta by cos theta is equal to tan theta. Similarly, we can say that cot theta is equal to cos theta by sin theta. Why? Because cot is the reciprocal of tan. That's why you'll get here. Tan is equal to sin by cos, cot is equal to cos by sin. These three are the basic informations about the trigonometric ratios and its reciprocal. Just keep in mind, because of in applications, while we are going to solve the problems, we will use these also. Next we'll go for one question, right? Up to now we know all the concept about the sin, cos, tan and reciprocal, and these are the note 1, 2 and 3, 4, 5 also. We'll go for a problem. For example, if 3 tan theta, otherwise 3 tan A is equal to 4. If 3 tan A is equal to 4, find sin A and cos A and cot A. This is one question based on the concept. If 3 tan A is equal to 4, then find sin A, cos A and cot A. The diagram, nothing but right angle triangle. Now, given this is the hint for us. Now, using the hint, we can draw the diagram, right angle triangle ABC, A, B, C. If you take right angle at B, Clearly they given from these 3 into tan A is equal 4. Now subject as tan A is equal to 4 by subject as tan A is equal to 4 by 3. Tan concept we know that. What we know tan? Tan nothing but opposite side by adjacent side. Now nothing but this is what? Opposite side by adjacent side. But from the diagram right angle triangle ABC, right angle at B clearly we know that. But where is theta? Theta is at A or C. That is one doubt. Now we'll go for simple. Now subject as tan A, nothing but theta is absolutely theta is at A. For example, tan C means theta is at tan C. Clearly they given that if 3 tan A is equal 4. So indirectly theta is at A only. Now theta is at A. Simply clear now we know that. The longest side is called hypotenuse. This is the opposite side. Why? Because the side which is opposite theta, because opposite side. Remaining side is adjacent side. Now this is what? Hypotenuse. This is what? Opposite side. This is the remaining side is adjacent side. From the concept tan A is equal 4 by 3. So opposite is 4, adjacent side is equal to 3. So opposite value is 4. This is the 4, adjacent value is 3. Now 3 we know, 4 we know. The length of AB we know, length of BC we know. Now length of AC is missing. Indirectly hypotenuse is missing that. We should calculate the value of AC by using the Pythagoras theorem. Pythagoras triplets. If you know the triplets, simply we can apply it without calculation, without simplifying it. If you don't know the triplets, now we'll go for the using the Pythagoras theorem concept. We know that Pythagoras theorem concept is hypotenuse square is equal to sum of the squares of the other two sides. The square of hypotenuse is equal to sum of the squares of the other two sides, nothing but what it is. One is opposite, one is adjacent side. This is the statement for Pythagoras theorem or Pythagoras triplet. Now hypotenuse square is missing that. This is for example x I am taking that. So x square is equal to opposite side value is 4, 4 square, adjacent side value is 3, 3 square. So x square is equal to 4 square nothing but 16, 3 square nothing but 9, x square is equal to 25. Now x is equal to 5 will get plus or minus, will take always positive. Now take the x value is 5. It's nothing but the value of x is 5. Now we know sides AB 3, BC 4, AC is 5. We know all the sides AB, BC, CA. Now we'll go for the what is sin A, what is cos A, what is tan A. Now sin A, sin A. We know the concept of sin. What is sin? It is sin is nothing but opposite side by hypotenuse. Opposite side by hypotenuse. Here opposite side is 4, hypotenuse is equal to what it is 5. The sin A value is 4 by 5. Next one cos A. So cos A, therefore cos A is equal to adjacent side by hypotenuse. So adjacent side is 3, hypotenuse is equal to 5. So 3 by 5. Next one is cot A. So cot A is equal, simply without calculation this is all. Why? Because tan A is equal 4 by 3. Cot A is equal, why? Because cot is the reciprocal of tan. So cot A is equal 3 by 4. Otherwise by using the concept cot is equal what we know here, cot. So 1 by adjacent side by opposite side. So adjacent side by opposite side. So now the answer is 3 by 4. Sin A 4 by 5, cos A 3 by 5, cot is 3 by 4 by using concept. So like this based on problems. So 3 tan A is equal 4, find sin A, cos A, tan A, or cot A. Otherwise if they ask a question, find the sec A, cosec A also. Like this we have to solve the problem. These are the applicable questions based on the concept. That's why we should recall the concept, then apply that, solve that. After that, take the concept from the sine, cos, tan, go for the solve the problem. Now we'll go for one more problem. If the sides of a right angle triangle QP are, one more question based on the concept. That is the first question. One more second problem based on the concept. The sides of the right angle triangle QP are, for example, draw the right angle triangle. This is the Q, this is the P, This is the R. Right angle at PL, they mentioned that. So the sides of the right angle triangle QPR, length of PQ is equal to 7 centimeter. Length of PQ, how much it is? 7 centimeter, clearly given that. And its hypotenuse, nothing but QR. Length of QR is equal to 25 centimeter. 25 centimeter. Find the value of tan Q minus tan R. Tan Q minus tan R. Now from the right angle triangle QPR, right angle at P, clearly they given that the length of PQ 7 centimeter, length of RQ is 25 centimeter. We should find the what is the length of PR. Side PR is missing that. Again, by using the Pythagoras Theorem, Pythagorean triplet, we should find the value of PR, length of PR. Now the missing term, missing length is X. I am taking that by using the concept hypotenuse square is equal nothing but 25 square is equal to sum of the squares of other two sides. Now X square plus 7 square. 25 square is equal 625. 25 ja X square, 7 ja 49. So now subject as X square is equal to 625 plus 14 become minus 49. Transfer to left side part. It will become X square is equal to, we get 15 minus 6 again, 576. Now X square is equal to 576, how to write it is 24 square. So therefore X is nothing but 24. Now X we got it is 24. The value of the length of the PR is equal to how much it is? 24. This is the length of PR. Now we know the 7, 24, 25. This is the Pythagorean triplet. I'll say one triplets, I'll say some examples of triplets. It is Pythagorean triplets. Keep in mind Pythagorean triplets. So one is 3, 4, 5. Next one is I'm taking 5, 12, 30. Next one 6, 8, 10. One more 7, 24, 25. This is what? 7, 24, 25. In the previous case 3, 4, and 5. 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25. One more. Already we know subject as it is 9, 12, 15, 9, 40, 41. Many are there here. So these are the some examples of Pythagorean triplets. By using formula also 2n, n square minus 1 comma 2n comma n square plus 1. But applicable some case one it applicable for the Pythagorean triplets. 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25, 9, 12, 15, 9, 40, 41. If you know these all these in objective purpose, it's better for that. Without wasting our time, simply we get the answers. If you know the triplets. Otherwise, you apply the Pythagoras concept, will get the value, no problem. Now we'll go for here 7, 24, 25. Now the concept now, what is our target is tan Q and tan R. Tan Q minus tan R. First of all, tan Q find out. Tan Q. So tan Q is nothing but theta is at Q. In this case, where is Q? Here Q. Now, for example, in the first case, theta is at Q. Why? Because tan Q. Now theta is at Q. Now this is the opposite side. This is the adjacent side. This is what? Hypotenuse. Now tan concept what we know? Opposite side by adjacent side. So now 24 by 7. So tan Q is equal to opposite side by adjacent side. Next one tan R. Now tan R. Tan R is equal to. Now in this case theta is at R. Now change the theta is at R. Changing. Why? Because tan R. Theta is at R. Nothing but S7 said PQ is the opposite side. Opposite side by adjacent side. Now 7 by 24. Tan Q value is 24 by 7. Tan R is equal to 7 by 24. Because in this case theta is at Q. In this case theta is at R. Theta is changing. Depend upon the question. Find the tan Q minus tan R. If you know the tan Q, if you know the tan R, then after getting the values, then simplify that. Tan Q minus tan R. Now we'll go for the problem. Tan Q minus tan R is equal to 24 by 7 minus 7 by 24. 24 by 7 minus 7 by 24. Cancellation. Now 7 comma 24 LCM. 7 4 because 7 is the prime number. Just simply multiply that. 7 4 is 28. 7 is 14, 168. So the LCM of denominator 7, 24 is answer is 168. Then do the cross multiplication. 24, 24, 576 minus 7, 7, cross multiplication, right? Now 7, 7, 49. Then simplify that. 16 minus 9, we get 7. 7 minus, all one gone, 6 minus 4 is 2. Now remaining is 5. 527 by 168. So therefore, tan Q minus tan R value is 527 by 168. This is the answer for the given problem. The second example for based on the given concept. Now we'll go for one more important concept in this topic, trigonometric identities. Trigonometric identities, and based on the identities also we'll go for some problems, examples. These are the two examples for the based on this basic concept. Now we'll go for the trigonometric identities. Trigonometric identities. Number 1, sin square theta plus cos square theta is equal to 1. This is the first trigonometric identity. Sin square theta plus cos square theta is equal to 1. Subject as sin square theta is equal to 1 minus cos square theta. Subject as sin theta is equal to under root of 1 minus cos square. These are its applications of the applications from the first trigonometric identities. First one, sin square theta plus cos square theta is equal to 1. Then subject as only sin square theta, means plus cos square theta become minus cos square theta. So sin square theta is equal to 1 minus cos square theta. Now here sin square theta, but here only sin theta, the power is transported to the right side part. It will become root of, under root of 1 minus cos square theta. Next one, subject as cos square theta. Cos square theta is equal to 1 minus sin square theta. Next, subject as cos theta is equal to under root of 1 minus sin square. If you know the first identity, then automatically we get the sin square theta, sin theta, next cos square theta, and cos theta will get. Sec square theta minus tan square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Now from this, subject as sec square theta is equal to 1 plus tan square theta. Subject as sec theta is equal to under root of 1 plus tan square theta. Now we'll go for subject as tan square theta. Now sec square theta plus 1 become minus 1, minus tan square become plus tan square theta. These two are interchanging that. So tan square theta. Now subject as tan theta is equal to sec square theta minus 1. So subject as tan theta, subject as tan square theta. Sec square theta, sec theta, tan square theta, tan theta. Now we'll go for third one, sec square theta minus cot square theta is equal to cosec square theta minus cot square theta is equal to 1. This is the third one. Cosec square theta is equal to 1 plus cot square theta. Subject as cosec theta is equal to under root of 1 plus cot square theta. Subject as cot square theta is equal to cosec square theta minus 1 under root of cosec square theta minus 1 is equal to cot theta. These are its applications based on the first identity, second identity, and third identity. If you know that these are all identities and its applications, use these applications in problems like a 2 marks and 4 marks type question.